Hello everyone. Today we will learn a new lecture, VLAN principles and configuration. In last lecture, we talked about Ethernet. We know that all the devices in one Ethernet are in the same broadcasting domain, but sometimes we want to separate them into several separate groups, and the devices in each group are in the broadcasting domain. So in that case, we need to use VLAN technique, which is virtual local area network. And in today's lecture, we will first talk about what is VLAN, why do we need VLAN. Then we will talk about the principles of VLAN and also the applications of VLAN. And finally, we will give some examples on how to do the VLAN configuration. First, let's look at why do we need the VLAN technique. Actually, if we look at the layer 2 Ethernet, there is a big problem, which is the broadcasting flooding problem. So assume that there are a lot of computers and switches here. Because all of these devices are in the same broadcasting domain, so the packet the broadcasting packet will be transmitted to all the computers. Then there will generate a lot of broadcasting traffic, which will degrade the performance of the total network. Look at this for example. Even if we doesn't transmit the broadcasting frame, only a unicast frame is transmitted, and we assume that only this frame is transmitted from PC1 until PC2, and assume that only the switch 1, switch 3, switch 7 has the PC2's MAC address and corresponding interface added in its MAC address table. But the other switches doesn't have the information of PC2 included in its table. So these switches don't know how to forward the packet. So there is one problem. See, if this packet arrives switch 1, it knows this is the correct outgoing interface. Then he can unicast this packet to next hop. But here, switch 2 cannot match the MAC address of this PC2 in its table. Then he doesn't know where to forward. Then he should simply flood this packet to all the outgoing links. And then maybe this one knows how to forward. So here is a unicast. But for this switch, if it still doesn't know, then it will still flood this packet to all the outgoing links. Then there will be a lot of junk traffic here, and here. Why this one doesn't generate junk traffic? Because maybe it has this MAC address in its table, and it knows that I'm not the correct forwarder, so I will simply discard. But however, if there are some switch doesn't know the interface of the destination, then there will be a lot of junk traffic all over the network. So actually, this junk traffic causes dramatic performance degradation in the network. Even sometimes it can fail the whole network. And besides, the security is another problem. This packet are only destined to this destination, but all the other PCs has received it, so it generates severe security problems. To solve these problems, actually the idea of VLAN, virtual local area network, has been proposed. The idea of VLAN is that although all these PCs are in the same multicast domain, but we can separate them into several logically smaller broadcast domain. For example, these PCs are in the same logic broadcast domain, and these this is another logical domain. This is the third logical domain, and this domain only includes these two PCs. So in that case, if PC1 want to transmit a packet to PC2, then they only broadcast to this domain, and the other PCs, because they are not in the same domain of this this computer, then these hosts will not receive junk packets, junk traffic. So that is the idea of virtual LAN. So we call this is a virtual LAN 1, virtual LAN 2, virtual LAN 3, and virtual LAN 4. To use this virtual LAN, we can separate the whole large broadcasting domain into several smaller logical broadcasting domains. That is the idea of virtual local area network. And now we will introduce the VLAN principles, how to define the VLAN and assign VLANs. So this is an implementation. Assume that you are the administrator of the network in one company. And in this company, you have two departments. One department is this one, include PC1 and PC4. Another department include these PCs. And we can separate them into different VLAN. So one department corresponding to one VLAN. Then the VLAN implementation will be like this. Any packet transmitted from a PC from one VLAN will only be transmitted down to the PCs within the same VLAN, but others cannot receive that packet. Similarly, this packet can only be transmitted to this VLAN. So the broadcasting has limited within the VLAN instead of within the total network. So the junk traffic problem and security problem has been solved. Okay, if we want to do this, actually one key question is that how can these switches know which VLAN the packet belongs to, and how do these switches know where to forward the packets to? So to solve this problem, actually we can add a tag in the packet and let the packet to include more information. That information, we call it the VLAN tag. That is actually a 4-byte identification for the packet. It identifies which VLAN this packet belongs to and which host they can only be forwarded to. So this is the detailed packet format. If we look at the VLAN frame, we will find that actually in the original Ethernet frame, there is no place to put the VLAN tag into it. So if we want to identify which VLAN does this frame belongs to, we need to add a new part, which is the AO2.1Q tag. And the format of this AO2.1Q tag is as follows. It includes 4 domains. The first domain is the TP-ID, and if the TP-ID equals to 8100, it means that this is a AO2.1Q tag, and this frame is the AO2.1Q frame. And then this is a 3-bit priority. It tells the priority level of this packet. And this is a flag. And finally, the most important part is the VLAN ID, or you can think of that the VLAN tag. It tells in this tag, this is the AO2.1Q tag actually. So in this tag, because the VLAN ID is included, so the switch, when receive the packet, can know which VLAN this packet belongs to. So that helps the switch to forward packet to the correct outgoing interface. And you see that this VLAN ID is 12-bit. So at most, we have 4,096 different VLANs at most. Okay, so this is the VLAN frame. We use this AO2.1Q tag and this VLAN ID to tell us which VLAN this packet belongs to. Okay, so with that tag information included, then you can see that if we want to transmit a packet from PC1 to the VLAN 10, then actually when they transmit it, and the switch can add the tagged frame, add the tag into the frame, so the frame becomes a tagged frame. And then when receive this tagged frame in switch 2, they can know, okay, they are destined to VLAN 10, so they should forward to this interface, but they cannot go from this interface. And similarly for PC2, they add the tag and then it is forward here. So until now, the VLAN, the logical broadcasting domain, can be achieved by adding such a tag in the frames. Okay, so that is the VLAN identification. Now let's look at if we already have this tag into the packet, then how to assign multiple interface in the switch to different VLANs. Okay, so actually we have a lot of different kind of assignment. We can assign the VLANs by the interface. So actually now we have 4 interfaces, for example, and we can let 1 and 3 into the VLAN 10, and we let the interface 2 and 4 into the VLAN 20. That kind of assignment, we call it the interface-based assignment. Also, we can assign according to the IPs or MAC address. So here, if we assign according to MAC address, then MAC1 and MAC3 belong to 10, and MAC2 and MAC4 belong to 20. Also, we can use this IP subnet-based assignment. So if they have already been assigned different subnet IP address, then look at this. PC1 and PC3 belong to the same subnet, right? 1.x subnet. And 2 and 4 belong to another subnet. Then we can use this to represent VLAN 10, and this one 2.x to represent VLAN 20. Also, we can assign according to different protocol. So, for example, if these two working on IPv4 and these two working on IPv6, then we can assign according to this difference. Finally, to combine all these methods together, we can use this policy-based assignment. We can combine different policies together, and we can both use the IP address, MAC interface, and MAC address to assign into different VLANs. So this is an example actually. Interface-based VLAN assignment actually is the widely used assignment, but however they have advantage and disadvantage. So for example, if we assign according to the interface, then you can see the benefit is that they can simply use the PVID to represent the VLAN assignment. Thus here the PVID means the part default VLAN identification. Actually, each interface will have a default VLAN ID, and the VLAN ID range from 1 to 4094. So if we configure this interface with this 10 and this one also 10 and these two 20, then it means these two interfaces are in the same VLAN. However, although this is very easy to configure, but if we need to move one PC from one interface to another interface, then actually we need to manually configure the interface again. So for example, originally this interface is for VLAN 20. But when we move this packet here, this PC here, then this interface should be configured as the PVID 10, right? So we need to manually reconfigure the VLAN ID. That's the disadvantage for interface-based VLAN assignment. Another kind of assignment which also usually used is the MAC address-based VLAN. So for MAC address-based VLAN, actually we are assigned the VLAN according to the MAC address of the PCs. So we need to give the MAC address of these two PC in the VLAN table. But actually here the advantage is that if we move the PC from one port to another port, then we don't need to reconfigure the VLAN ID because the MAC address of the PC doesn't change, so they can automatically recognize this PC and know which it belongs to. However, the disadvantage is that they need to maintain a mapping table. In this table, they maintain for one MAC address which VLAN ID they belongs to. Okay, now we have introduced how to assign different interface into different VLANs. Now we will talk about some detailed things. So one important thing is that for every interface, actually we should not only configure its VLAN ID, but also we should configure its types, the interface type. So actually there are three different interface types: the access interface, the trunk interface, and also the hybrid interface. Typically, this access interface are used for the interface which is connected with the end system, the host. And for trunk interface, it is usually used for the interface which are connected between the switches and routers. And hybrid actually is the hybrid of these two types. They can be the combination of the functions of these two types. Now let's introduce each type one by one. So the first type, and which is very frequently used interface, actually is the access interface. This interface is used for to connect with the host. So the rules will be like this. In every interface, we will have a default VLAN ID, and every packet sent through this access interface should have a tag, should have a VLAN ID included in the packet. So how to add this tag, the rule is like this. So if one packet goes through an access VLAN with ID 10, then the tag should be added and the VLAN ID is equals to 10. And if this one receive a tagged frame, and if the tag equals to its default ID, then they can be forwarded up. But if this tag is different from this ID, then this should not be forwarded and be simply discarded. And similarly, for the sending part, it's also like this. If we receive a tagged packet and its tag equals to the VLAN ID, then they will think that, okay, this packet is for my VLAN, and I should remove the tag to recover the packet to be its original format and then send to the host. But if there is a different tag, then they saw that, okay, this is a wrong packet. It should not be forwarded to my VLAN. So I should simply discard it. So that's the action of the access interface. So you can see that the access interface actually is used for the interface to connect the host and to assign the tag to the host and confine a correct packet sent through the interface. But the incorrect packet, the packet belong to other VLANs, will not be limited to transmit through a different VLAN. Okay. Now let's look at what is the trunk interface. Actually, the trunk interface, as we have already said, they should be used in the interface which is used to connect a switch with another switch or a router. So this trunk interface, actually, they should allow multiple the packets from multiple VLANs go through it. Okay, so think of the previously talked access interface. For example, this is an access interface. They only allow 10 VID 10 packet go through, but this trunk interface will allow both 10 and 20 packets go through, right? How to achieve this? Actually, we can use this as an example. So for the trunk interface, actually they will have two things defined in the interface. One is its default PVID, port virtual LAN ID. Another one is the permitted ID. So that means which PVID packet are allowed to go through this trunk interface. So for example, in this example, the PVID of this interface is 1. So it corresponding to this one, the PVID is 1. But they allow both 10 and 20 go through. Also, it allows itself to go through. So actually, the permitted VLAN ID will be 1, 10, and 20. Then, if here is an untagged frame coming in, then they should give the default PVID tag into it. So they have 1. And if 1 is in the permitted list, then this packet can be allowed to go through to the to forward to the other interface. And if one packet has already a tag in it, then they should compare this with the permission list. If it is in the permission list, then they are allowed to go through. But if it's not in the permission list, then they are not allowed to go through. Here, because multiple tags are allowed, so actually multiple packets from multiple VLANs can come through this trunk interface. This is for frame receiving. And for frame sending, similarly, when we receive a packet with a tag and this tag is listed in the permission list, then they can simply let it go through it. But if comes a packet and the tag equals to its own default PVID and also it is permitted, then they will think that, okay, this is a packet I have inserted previously. So actually here I should recover it back to be an untagged frame. So the trunk interface actually allows the packet with its own default PVID to be decapsulated and untagged and transmit out. Okay, so you can see that if we use this trunk interface, then the packets from other VLANs will keep the same to be forwarded to the other VLANs. And the packets which is untagged coming in, then they should be added with its own tag and then be decapsulated here to become an untagged packet here. So through this trunk, the untagged packet are still untagged packet, and the tagged packet are still tagged packet. Okay, so by using the access interface and this trunk interface together, we can allow such VLAN configuration. So by configure these 4 to be access interface and these 2 to be trunk interface, we can allow PC from PC1's packet originally no tags, and then add a tag 10, and then here switch can use this tag 10 to see, okay, so if this packet come to this interface, it is allowed to go out. But if it arrive here, then it is not allowed to go out. Similarly, for 20, they are allowed to go from this interface, but they are not allowed from here. So we actually can achieve the VID separation, right? So this and this to become one VLAN, and this one becomes another VLAN. So this is the application of access and trunk interface. Okay, so you need to know that these are access interface, these are trunk interface, and you need to be very clear about how they process the packets. Okay, now let's look at what is the hybrid interface. Actually, the hybrid interface is a combination of these 2 kind of interface, the access interface and the trunk interface. The key difference is that for hybrid interface, they have 2 permission lists. One is the tagged permission list, another is the untagged permission list. And the main difference between the hybrid and the trunk is that for trunk interface, you see here, yeah, for trunk interface, there are only one untagged packet allowed to come out. That is, if the PVID equals to its own, the tag equals to its own PVID, then they can be untagged here, right? But for hybrid interface, actually they allow multiple tags to become the untagged packet to transmit out. Okay, so here is an example. The frame receiving process of the hybrid interface are exactly the same with the trunk interface. So if it's an untagged, then put in the tag. If it is tagged, then check whether it's permitted. So it's just the same with the trunk. But for this frame sending, they are a little bit different. If there is a packet coming in, they should check it within its tagged permission list, and both untagged permission list. If this one exists in the untagged permission list, it means this packet should be changed into an untagged frame to send out. So they should remove the tag and then send the untagged frame out. And if this packet is within the tagged permission list, then they should not remove the tag. They should just simply forward out with the tag left in. That's the only difference. So actually you can see here, if it's trunk interface, only if this number equals to the default PVID and this number is in the permission list, it can be untagged. But here, it doesn't care whether this equals to its own PVID. Only if it is listed in the permission untagged list, then this can be forwarded with untagged frame. That's the only difference between the hybrid and the trunk. So why does the hybrid interface should work like this? Actually, we can use this example to illustrate. So assume that we have two switches connected with each other. We have two PCs belong to two different VLANs, and we have one server belong to another VLAN. And here we configure all these interfaces to be the hybrid interfaces. Okay, and for each interface, they actually will list two permission lists. One is this untagged permission list. Another one is the tagged permission list. Here, for example, the port 1 have no tagged, the tagged permission list actually is 0. And here, for the port 3, the untagged permission list is 0. Okay, but they will have they have two different types of permission list. And then, how does the switch do the forwarding? Actually, it will be like this. So first we look at the packet from VLAN 10. This is untagged because it is sent by PC. And then in the switch, they will check whether this ID equals to is in the permission list. So here you can see that in port 1, 10 is in the permission list. Then they can simply forward the packet. They will add the PVID here. So the PVID is 10 and then send the packet out. Okay, so this packet becomes a tagged packet. And then the tagged packet, when it arrives port 3, they will check here in port 3 that this 10 is in the tagged list. So they are permissioned to send out, and you don't need to decapsulate the tag. So they will keep the tag in and transmit out. Then in switch 2 in port 3, here, switch 2 port 3, they check for 10. Yeah, they are still in the tagged permission list. So they are permissioned to be transmit. And then they go into the port 1. In the port 1, in port 1, they see that, okay, first it is permissioned. Secondly, they are in the untagged permission list. So the 10 can be allowed to transmit out, but they should be removed by the tag. So here is the packet. Okay, so they becomes untagged packet to the VLAN, to the server. So this is the example for a packet from PC 1. And similarly, for the packet from the server, actually they will be added by 100 in the port 1 here, and then they will send out. And then because 100 is in the port 3's tagged list, so they can be transmitted out. And still they are here, so they are be transmitted in. And then they are here, so but because they are untagged, so when the packet 100 go out, actually that is untagged, and that is a untagged packet received by packet 1 and packet 2. So this is an example for the hybrid interface. So you can see that actually if this is a hybrid interface, both the tagged packet and untagged packet can be transmitted out. Okay, and which one is transmitted out? They can check it according to the list, permission list. Okay, so that's all for the interface type. Actually, this is very important because when you configure the switch, you need to know which kind of type of interface is suitable for the detailed scenario. Okay, so this is a summary. So for access interface, when they receive a frame, if they don't have the tag, then they will simply add the PVID. If they have already tagged, then they will check whether it's the same with the PVID. If it's same, permit to transmit. If not, discard. Then for frame sending, if the access interface receive a frame and want to send out, then the only thing they need to do is to check whether the tag equals to the PVID. If it's equal, then remove the tag and send out. This is for the correct VLAN, and otherwise they will discard the frame. That's all. And for trunk interface, if they receive the frame, if they receive untagged frame, they should add the VLAN VID into it and check whether it's permissioned. If yes, allow it to transmit. If not, discard it. And if it's tagged, then check whether they are in the list of permission ID. If yes, send it. If not, discard it. And for if they receive a frame, want to transmit out, then they will check. First, they will check whether the VID is in the permission list. If it's in the permission list, then allow to transmit. And if it's equal to the PVID, then they should remove the tag and send out. If it's different from the PVID, then just send out. And if it's not in the list, then discard the frame. Okay. Finally is for hybrid. For hybrid, when they receive a frame, that is the same as the trunk. But the only difference is that when they send a frame, they should match the VID with the permission list. If they are in the untagged permission list, then they should remove the tag and send out. If they are in the tagged permission list, then they should forward the packet without removing the tag. That's all the process of the different type of interfaces. Okay, now let's look at the application of VLANs. We will first discuss how to do VLAN planning. Actually, VLAN planning should follow several assignment rules. For example, we should assign VLAN by service. Different services should be in different VLANs. And also, we can assign by department or by application. Different devices from department or from different applications should belong to different VLANs. So this is an example. And also, we need to assign continuous VLAN subnet to different VLANs. So, for example, let's look at this network. Assume that we have three buildings. And in the first building, they have office, classroom, and financial section. So they will have three sections. This is office, this is classroom, and this is financial section. So we can assign each section with a VLAN. So VLAN 1, VLAN 2, VLAN 3, and teaching building with office. So VLAN 1, and the classroom, VLAN 2, and then the office building with office, VLAN 1, and financial, VLAN 3. So this is the architecture. And these three switch actually are connected to a call switch. Okay, so that is the architecture of this VLAN, of this building, of these three buildings. Now we should assign different subnet into different VLAN. So we should assign, for example, this 10.0 for VLAN 1, and this 20.0 to VLAN 2, and 30.0 to VLAN 3. That's all for the VLAN assignment and IP address allocation. Okay, so this is an example. We have learned two kinds of VLAN assignment. For example, we have the interface-based VLAN assignment and also the MAC address-based VLAN assignment. Now let's look at which application scenario should we use this interface-based and at which scenario we should use the MAC-based. So first, let's look at the interface-based. Assume you are in such a scenario. So you are the administrator of a building, and in this building, you actually provide service for 3 different enterprises. Then probably you should allocate your devices for these 3 enterprises, and you want them to share all the switch routers, these devices. But to guarantee the separation of the access of these 3 different enterprises, you need to give this enterprise with separate VLAN. So one VLAN for one enterprise. In this case, because each enterprise may occupy several offices and they will not change office with each other. So you can simply let the VLAN combined with the interface, and then they are fixed. They will not be moved later on. This is the application scenario for the interface-based VLAN assignment. The interface connected with enterprise 1 to VLAN 2, and the interface is connected with this enterprise to another VLAN, then that's okay. Then each VLAN works as a virtual work group and they cannot access with each other. So that's the application scenario for interface-based VLAN. However, if we think of another case, for example, now you are not the administrator of a building, you are the network administrator of an enterprise. Then under your enterprise, you have several employees, and each employee will bring their own laptop or their PCs. Then actually you will allow only these PCs to access your enterprise network. If the PC are not authorized, then they should not access. So in this application scenario, actually the MAC address-based VLAN assignment will be more suitable because you can give these PCs with the listed MAC address the permission to access your network. But if there comes another computer, their MAC address is not in the allowed list, in the permission list, then it cannot access this network. Even if one employee bring another network, he cannot access. Bring another PC, he cannot access. So this actually allows a secure access in your enterprise. Okay, so that's 2 typical application scenarios. Now let's look at how to configure all these above principles in the applications. First, let's look at some basic VLAN configurations. So actually, if we want to configure the VLAN, first we need to create a VLAN. Okay, so using this command, or we can create multiple VLANs. So we can use VLAN batch to create multiple VLAN from VLAN 1 until VLAN several. Okay. Now, if we have already create a VLAN and we need to set the interface type for every interface. Now let's look at how to set the access interface. If we want the interface to have the type of access, then what should we do? Yeah, actually we can use this command. We set the link type to be access, and then we can just give this interface or this port one default VLAN ID. That's all. Okay. So with this VLAN ID, they can transmit through this interface. But without this ID, they can, if it's a packet with another VLAN ID, then they cannot be allowed to transmit through this access interface. How about to construct a trunk interface? Yeah, That's also easy. So first you need to give the type to be trunk, and then you need to set the default VLAN ID. So this is the default VLAN ID for the trunk interface. And finally, you need to give the permission list, which the packets from which VLAN can be permitted to go through this this interface. Then so you can use this command, which is pod trunk allow path VLAN, include several VLAN. Okay, so that's all configurations for trunk interface. Next one, let's look at how to configure hybrid interface. So for hybrid interface, also you need to set the type, you need to give a default VLAN ID, and also you need to give the permission list. But here, you should give two different permission lists. One is for the untagged permission list. That means only the packets belong to this VLAN list can be sent out with untagged format. And also you need to give the tagged permission list as this one. Okay, so that's the basic configuration for hybrid interface. Now let's use several detailed examples to learn how to use the basic VLAN configurations. First, let's look at this example. So if we want to configure using the interface-based VLAN assignment and assume such a network, we have two switches and they are connected with each other and they provide access for two different VLANs. Okay, now let's look at how to configure. Actually, we should configure the interface connected with the PCs as the access interface, and we should configure the interface connected with switches as the trunk interface. Okay, now this one we first create the VLAN in switch 1. We need to create VLAN 10, VLAN 20, and that's all. Okay, or we can use this command to create multiple VLANs. Now let's configure the interface one by one. So for interface 1, we need to set its type as access and give the default VLAN ID as 10. That's all. Similarly, for interface 2, we can also use these two commands to do that. Or we can use another way to configure. For example, we can go into the interface and to give it a VLAN ID, or we can go into the VLANs view and combine and bind the port with this VLAN. Okay, so after this, these two configured successfully. And then for interface 3, for this one, the type is trunk. For the default PVID is 1. And then which VLAN ID we should allow to pass? Actually, we should allow both 10 and 20. So this command, that's all. Then let's check whether it's correct or not. So we can check the VLAN by command display VLAN. Now we can see that besides the original existed default VLAN, VLAN 1, we have already created two more VLANs. And for each VLAN, we have its corresponding port. So for 1, we only have the port 3. And for VLAN 10, both interface 1 and interface 3 can allow VLAN 10 to go through. But one is untagged, one is tagged. Similarly, for VLAN 20, we also have two interface binding with this VLAN. Okay, so the configuration is successfully configured. Now let's look at another example. If we need to set up the interface as the hybrid interface, how to do the configuration. Now, in this example, because these two VLANs traffic want to communicate with another server, so we can use hybrid for all these interfaces. Now, the configuration will be like this. First, let's go into the switch 1, and then we create 3 different VLAN, 10, 20, and 100. Interface 1, we should configure it into hybrid interface, and then we should give its default VLAN ID, which is 10, and then we should set the tagged permission list and untagged permission list. Here, because all the packets go from this interface should be untagged, so we only give the untagged permission list to be 10 and 100. So packet from this can go into it. Packet from itself, VLAN can go into it. Okay. So yeah, and finally we need to assign the interface. That finished the configuration of port 1. Now let's go into the interface 2. And similarly, we should set the type, set the default ID, and set the untagged VLAN. That's all for interface 2. Now let's go into interface 3. And in interface 3, we only need to set the type and the tagged permission list, because all the packets from here should be tagged, and they have no their default PVID is 1, so we don't need to reconfigure it again. Similarly, for switch 2, we can configure for the interface 1 and interface 3. Each one, this one is similar as this one, and these are similar as this one. So finally, we can check our configuration by display VLAN. We can see that in switch 1, we have 4 different VLANs. So for VLAN 1, they only have this untagged interface, 1, 2, 3. And for 10, actually both interface 1 and 3 are allowed. And similarly for 20, both 2 and 3 are allowed. And for 100, both 1 and 2 are allowed. Okay. All 1, 2, 3 are allowed. And you can see that for this interface, that is untagged, and for this interface, that is tagged. So the configuration is successful. Okay, we have already introduced how to configure the interface-based VLAN. Now we introduce how to configure the MAC address-based VLAN. So these are the basic configurations. We need to do the association between the MAC address and VLAN using this command. And also, in the interface, we need to enable the association between MAC and VLAN. So that's all for basic configuration command. This is the example. So now, if we want to configure the VLAN 10 by assign its MAC address, then we should do the following configurations. So first, we need to create VLAN 10, and then we should go into the VLAN 10 to use the MAC VLAN MAC address to associate the MAC address with this VLAN. So we have 3 different MAC addresses to be associated with VLAN. And then we should go into the interface to give the type of the interface, and also give the default VLAN ID. So for this interface, we should set it as hybrid, and we should give the VLAN 10 to be the permissioned tagged VLAN ID. And also for interface 2, we have the hybrid setup, right? The type link, the links type should be hybrid, and also we should give the permissioned VID, and the permissioned VID is untagged. It's 10. So similarly for this one and this one, we should all configure using these two commands. And finally, we should do the MAC address VLAN association. So we need to enable the MAC and VLAN association. So we need to go into the interface 2 to do the MAC VLAN enable. So after these three steps, after we associate the MAC address with VLAN, after we set the link type of the interface, and after we enable the MAC and VLAN association, the address-based VLAN assignment has been successfully configured. Okay, so now let's verify the configuration. So if we display VLAN, then we can see there is one VLAN 1, there's VLAN 10, and for each VLAN, the corresponding interface are associated. And if we look at the MAC VLAN association relationship, actually that is using this command to see. And you can see that there are 3 different MAC addresses associated with VLAN 10. So the configuration is successful. Okay, so that's all for this lecture. Actually, in this lecture, we described the VLAN technology, why do we need a VLAN, and how to configure the VLAN. We learned the functions, the identification, the assignment, the data exchange, the planning application, and also the basic configurations of VLAN. Actually, the VLAN technology can divide a physical local area network into multiple virtual local area network. And these virtual local area network has its own broadcast domain, so that the network device in the same VLAN can directly communicate, but the devices from different VLANs cannot. Okay, so that's the basic motivation of VLAN. And now you should know when to use VLAN and how to configure the VLAN in different applications. Okay, so that's all for today's lecture. Thank you.